We've got a really interesting part today. This is a traditional mold tool, and these are produced one-off, and then they're used in injection molding to create masses of parts. And this is exactly what this part is. This is a mudguard for a motorcycle. Now, traditionally, this is machined as a one-off, as I said, but it's also machined out of a very hard material, a tool steel material. There's a number of sort of key bits of geometry on this model or on this part today. So we've got some sort of free-form surfaces. We've also got some complicated or complex geometries on the inside of the pocket. How would you traditionally go about machining this part?
Right, so after completing all the roughing and rest roughing stages on the job, I would then look to finish the steeper regions using a contour strategy. Contour is very good from anything from 30 degrees up to 90 degrees.
Right.
It gives you a constant step down, giving a real nice surface finish.
Okay.
I would then machine the flatter regions. We'll have a choice of either a scallop machining or parallel machining.
Got ya.
And that will give us a nice even finish all the way across the flatter areas.
Okay. This is actually a really good point. Fusion 360 has just introduced a brand new toolpath called Steep and Shallow. And what this does is automatically identify the steeper areas of the part, as you've just mentioned, but also focuses on the shallower regions and then optimizes those individual regions of the toolpath and combines that into a single toolpath.
Right, so I can now calculate just one toolpath to machine the mold instead of two.
Absolutely. With the new Steep and Shallow strategy, there's a lot of benefits to using the strategy that you may not be aware of. But sort of the main benefit of this is that we get an improved machining time, but we also get an improved surface finishing as part of that toolpath. So let me explain some of those benefits. Benefit 1, continuous spiral for an improved surface finish. When using the scallop option on shallow areas, the new Steep and Shallow strategy has the option to use continuous spiral. Now what this means is that the tool does not have to perform a step over between passes across shallower regions. Now this has the obvious benefit of reducing the cycle time, but the biggest notable benefit here is that with no steps between passes, we get an overall better surface finish. But also notice that there are no more linking passes when using the continuous option. Benefit 2, corner smoothing and automatic cusp removal. Notice on screen the sharp corners in this particular toolpath segment. Now when the machine tool sees the sharp corner coming up in the toolpath, it will automatically try to reduce the programmed feed rate. And this allows the cutting tool to change direction as it enters that particular sharp corner. Now this does two things. Firstly, when the feed rate slows down, the cutting tool stops deflecting. And this can ultimately result in a small dwell mark being made on the part. Secondly, when the machine tool automatically reduces that same feed rate, the machining cycle time also increases. By eliminating all of those sharp corners from the toolpath, we can make the machining cycle time faster, and it improves the overall surface finish. Now it's particularly important at this point to note that the new Steep and Shallow toolpath has a centerline trace as its final cutting action. The centerline cut passes all over the small apexes to remove the tiny cups of material where the cutting tool smoothly changed its direction on the scallop toolpath. Generally, this is just a nicer toolpath with a faster cycle time, resulting in a better quality surface finish. Benefit 3, constant overlap between steep and shallow regions. Okay, so users of the new Steep and Shallow toolpath strategy can now enter an overlap value. Without this overlap value, the toolpaths for the steep regions and the toolpaths for those shallower regions step over at the same edge. And this can result in dwell marks appearing on the surface finish of the machine component. Entering an overlap value will result in the toolpath for those steeper regions and the toolpath for those shallower regions overlapping by a user-defined amount. By adding an overlap between the adjoining areas of the steep and shallow toolpath, We ultimately improve the surface finish by slightly overlapping the edges of the toolpaths. By doing this, we extend the edges of the toolpath segments so that they step over in different locations, ultimately minimizing the dwell marks. Benefit 4, wall clearance with parallel. When machining shallow areas, one can also use the parallel strategy for shallow areas instead of the scallop toolpath. You can see that as we machine the bottom of this deep pocket, at the end of each parallel pass, the tool is going to approach the side wall of the pocket. This new steep and shallow toolpath strategy leaves the parallel passes slightly short of the steep wall, and so as to avoid the tool touching the wall of the pocket. The amount of gap left is controlled by the user and is user-defined, and it avoids the cutting tool touching these steep pocket walls, which would otherwise cause marks to form on the steep faces of the pocket. Now, we often refer to these marks on the side wall as being pecker tracks. Using this pullback value will result ultimately in a better surface finish, especially on the steep faces of the part. Benefit 5, automatic parallel angle. The new steep and shallow toolpath strategy allows the user to select an auto angle option, which will change the way the shallow regions of the toolpath are calculated. When the auto angle option is activated, the optimum parallel toolpath angle is automatically calculated by Fusion 360 for each of those individual shallow regions of the toolpath. So you can now see in the toolpath that each shallow region has a different parallel angle. The angle for each of these regions is automatically calculated to minimize the toolpath length, resulting in a faster and more efficient machining toolpath.
Okay, great. So we get set up and do some machining?
Absolutely, let's do it.